Hi guys. We finished class today, or not finished, but when we got about halfway through class today, I did an in-class demo, I guess, leading to an example problem where I took one of these Nerf guns here and just cocked it. Let's see, and I fired it off with my arm pointed kind of horizontal. So I was standing up and my arm was pointed horizontal, and I just fired that bullet, okay, or that dart. And then we measured how high up above the ground my arm was, or the bullet was, or the dart was when it got fired. And I also measured how far the dart traveled in the horizontal direction. So both how far up the dart was and how far it traveled in the X direction. And I asked us to, from those two pieces of information, I asked us to determine what the speed of the dart was when it left the gun. All right, so that's our problem. Based on initial data for height of the dart and how far the dart travels, figure out the speed that the dart leaves the gun with. All right, so that's what we're going to try to work through here. And the way I'm going to do that, first off, is that I am going to give us a blank page to work on. Eventually, there we go. And so we'll just get rolling on this. So first thing I should probably do is draw a sketch. So we'll put a dart right there, and then let's see, it traveled this away and it struck the ground right over here. Okay, and we were able to measure in class that it started out from a height of 1.5 meters, and that it traveled a distance in the X direction of 6 meters. And our goal here, as I said, our goal was to figure out, well, what is the initial velocity that this dart is launched at? Okay. So at the very moment it leaves the barrel of the gun, how fast is it going? All right. So at the very moment it leaves the barrel of the gun until it strikes the ground, the only thing that's working on it, the only force that's working on it is gravity. The only acceleration we should have for one of these darts is just an acceleration in the Y direction once the dart leaves the gun. So let's start drawing out tables. Let's see, in the X direction, what do I have? I've got displacement. My displacement is 6 meters. My initial velocity in the X direction, I don't know that. My final velocity in the X direction, let's see, I don't know that. Acceleration in the X direction, well, once the dart leaves the gun, nothing is working on it in the X direction. It has no acceleration in the X direction. It's just a projectile. The only thing working on it is gravity. Okay, and how much time is it in the air? Well, I don't know. Okay. Let's see. If I look at my my kinematic equations and write it out in the X direction, V is equal to V naught xt plus 1/2 a xt squared. That's one of my kinematic equations. And then I notice that my acceleration in the X direction is 0. So that entire term is just going to go away. And this whole thing is going to reduce to just that my displacement in the X direction is equal to the initial velocity in the X direction times time. All right. Now that right there is as far as I can get in the X direction, because I know the displacement. I don't know the initial velocity. I don't know the time, so I'm stuck. So what I need to do from here is turn around and look at, whoops, figure out what's going on. Oops. There we go. I need to look at my motion in the Y direction. Okay, so in the Y direction, my displacement in Y is, let's see, it starts up high and drops lower. So its displacement is going to be a negative 1.5 meters. It's dropping down lower. It's losing height. its final position is lower than its initial position. So it's going to be a negative 1.5 meters. Let's see, initial velocity in the y direction, final velocity in the y direction, acceleration in the y direction. Well, we know acceleration in the y direction is negative 9.8 meters per second squared. And then time, we definitely don't know time. All right. So a couple things here. We might think about the final velocities. How fast was the dart going in the y direction when it struck the ground? And we might be tempted to say, well, after it strikes the ground, the velocity is 0. But I don't care what the velocity is after the dart strikes the ground. I care what it is when the dart strikes the ground. And so for projectile motion problems, if we're talking about the velocity of an object, when that object strikes the ground, that value is never going to be 0. We want to know just how fast it's moving at the exact instant it hit. So I don't know the final velocity here. I can't say that the final velocity in the y direction is 0. But that said, I did something very specific with this gun when I fired it off. I tried to make sure that my hand was pointed horizontal, so that when the dart left the gun, it was traveling horizontally to start with. So initially it had a horizontal motion. Well, if that motion was horizontal, then that leads us to, let's see, if it was horizontal, that means it wasn't initially traveling in the y direction at all. So anytime we see this horizontal motion, that tells us that, well, at that moment when our object was traveling horizontally, our velocity in the y direction was 0. So we can fill that into our table right there. From our starting point to our ending point right there, we've got our two tables in the x direction and the y direction. And if I look at that y direction, it looks like I've got 3 of 5 things, which is awesome. That means I can figure out the other 2 if I want to know them. All right, so let's do that. Let's find t based on that information. So looking at my equations, let's see, I think the one that I want to pick is y is equal to v naught. Y is equal to v naught yt plus 1/2 at squared. And let's see, my initial velocity in the y direction, we said this was 0 because the dart initially is traveling horizontally. So that's 0. That is going to leave me then with what? Y is equal to 1/2 a sub y t squared. I can start rearranging this equation to solve for time. It looks like t is going to be equal to the root of 2y over a sub y. And let's fill in the numbers there. That's 2. That's 2 times negative 1.5 over negative 9.8 for my acceleration in the y direction. All right, and this looks like 0.55 seconds approximately. There we go. So that's how much time it's in the air. While we're at it, we've got another unknown in that table for the y direction. Let's just go ahead and figure out what our final velocity is in the y direction. Why not? Final velocity in the y direction is equal to initial velocity in the y direction plus acceleration in the y direction times time. The initial velocity is 0. This is negative 9.8 meters per second squared. I now have my time. The time is 0.55 seconds. And when I plug this in, I get a velocity in the y direction of negative 5.4 meters per second. Okay, and we'll just go ahead and put a box around that too. Let's back up. There we go. Okay, and let's see now. I'm back at my table. This v sub y is negative 5.4 meters per second. And this time is 0.55 seconds. 0.55. That's a mess. 0.55. Okay. All right. Well, let's see. If the dart had 0.55 seconds to travel in the y direction from when it was fired, well, it also had 0.55 seconds to travel in the x direction when it was, from when it was fired. Let's see. It left the gun. It went in the y direction, went in the x direction, and it struck the ground. So yeah, it traveled for 0.55 seconds in the y direction. It traveled for the exact same amount of time in the x direction. So we can put that into our table for x. That time is 0.55 seconds. All right, and now if we look at our boxed equation here, we've got the displacement in the x direction. We've got the time. We've got the time in the we've got the time period. So we can go ahead and we can solve this boxed equation for initial velocity. V naught x is equal to x over t. This looks like 6 meters over 0.55 seconds. And what do we get out of that? We get an answer of 10.9 meters per second. All right. And because of the fact that this dart wasn't moving in the y direction at all at the moment it was fired, because of the fact that our v naught y was 0, then our initial velocity is just going to be exactly what we calculated for the initial velocity in the x direction, because it has no y component. That's a special condition of this particular problem. So there we go. Our initial velocity in the our initial velocity period is 10.9 meters per second. And that's what we were asked to solve for on this question. All right. So we got that squared away. That's all I asked for. But, while we're at it, let's figure out what the final velocity was too. I'm going to need a little more space for that. Okay. So let's take a look. I'm going to zoom in here. There's the ground. And let's see, this dart, when it hits the ground, it's traveling, I don't know, something like this. Okay. So that's, the dart when it hits the ground is traveling in that direction. And let's see, we can break that velocity vector down into x and y components. I did kind of a lousy job there, but there we go. That's in the x direction. This one's in the y direction. And we know what those components are. We just figured out that our velocity in the x direction is 10.9 meters per second. And that velocity is constant because we've got no acceleration in the x direction. That velocity doesn't change because we've got nothing to accelerate it in the x direction. Okay. On the other hand, in the y direction, we do have gravity. We figured out, as an aside, while I was filling out that table, that our final velocity in the y direction was what? Negative 5.4 meters per second. I'm going to drop the negative sign because I've got a triangle there. Triangles don't have negative side lengths. So in order to do this analysis, I'm just going to say that the length of that vertical leg of my triangle there is 5.4 meters per second. All right. So my final speed, my final velocity will have a magnitude of, let's see, this looks like Pythagoras to me. The root of one side of the triangle squared plus the other side of the triangle squared. All right. And what do I get out of this? I get 12.1 meters per second. So this right here, this is my final speed. Or I could also say that this is the magnitude of my final velocity. Okay, cool. Let's figure out one more thing while we're at it. Let's figure out the angle that this thing strikes at. Tangent is equal to opposite over adjacent. So the opposite side from the theta there would be v sub y. The adjacent side would be v sub x. So it looks like theta is going to be the inverse tangent of 5.4 over 10.9. And what do I get when I put that in? I get 26.3 degrees. And let's see, I need a reference line to tell what I'm measuring this 26.3 degrees off of. The struggle's real. There we go. What am I measuring it off of? I would say that this is below the horizontal. So that's one way I could describe that. My picture shows it too, but that's maybe how the words that I might choose to use. 26.3 degrees below the horizontal. Okay, that is all I have for this one, guys. So I should stop recording now. Okay, there it is.